Welcome back. Hopefully that example went pretty well for you, and now it's time to talk a little bit about current. We saw in the previous discussion that electrons move from place to place based on their potential energy, or if we think about it even more closely, based on where the other electrons are, where there are an abundance of electrons or where there are absence of electrons, therefore sort of an abundance of protons. That motion is known as current. And I mentioned to you at the time that we talked about voltage, that voltage was one of the most important quantities for an electrical and computer engineer. Current is the other one. So voltage and current, these are the two faces that would be on Mount Rushmore if we had a Mount Rushmore of electrical quantities. So current and voltage, I want to emphasize really clearly that those are the two quantities we're going to be working with the most. Now, it turns out that current is just defined to be the change in charge passing a certain point over a certain amount of time. So you can imagine, for example, if you were watching cars go past a certain point in the highway, you might count 100 cars in 10 minutes, and you'd say, okay, well, I can figure out what is the amount of cars per unit time. Or if I were watching the amount of water that's flowing over Niagara Falls, I could say, okay, that's a certain number of gallons per hour. I can figure out how many gallons per hour are going to flow over the edge of Niagara Falls. So we can talk about calculating a current, and that current is going to be as a result of voltages. And so we can, when we have the voltage and we can calculate the current, that's going to be the most important thing for circuit analysis that we're going to be doing. Now, there's one little tiny complexity here before we wrap up our discussion of current, and that is just a sort of an historical anomaly. We just had kind of bad luck because Ben Franklin happened to pick the wrong quantity. And as it turns out, as I mentioned to you last time, electrons are the things that actually flow around the circuit. And unfortunately for us, electrons have a negative charge. So it turns out that current is defined to be the motion of positive charges. And as the electrons are moving, yes, they're leading to current, and unfortunately the current's going in the opposite direction of the motion of the charges. As you can see here in figure 4, if protons were moving, and there are some times when protons move, usually we have to do a lot of work to make them move, but when they do move, they're going to be moving in the same direction as the current. That would be the easy case. But the more common and the more complex case is shown on the right-hand side of figure 4. That's where the electrons are moving, and unfortunately the current's going to be moving in the opposite direction of the electrons. Now, 99.9% of the time, you don't need to stress out about that. Most of the time, we're going to find that we just think about the current. We don't think about, oh gosh, yeah, the current's flowing from right to left, so therefore the electrons are flowing from the opposite direction, from left to whichever way I just said. So it's really a minor detail. You don't need to stress out about it. Usually, when I'm thinking about current, I think about positive charges flowing in the same direction as the current. Yes, I know that that's really not the case, but I do think about it in that way. And keeping that picture in mind will make your life a lot easier. It will reduce your stress level. It'll make it so that you can be able to handle the problems without one more thing to worry about. Okay, so now you should be ready to do your self-check analysis on calculating current. There's an example problem. I would suggest you work the example problem and then watch the video, and that should prepare you for talking about the relationship between voltage and current in sources. Thanks for your attention.